In this video, I want to show the commands required to leak routes between VRFs, specifically an external requirement of a VRF or multi-tenant VRFs on border leaves in a VXLAN EVPN Fabric. So in this example, we've got two tenants. We've got overlay tenant 1, overlay tenant 2, two different L3 VNIs, and then we've also got an external VRF which lives on leaf 3 and 4, which connect out to this firewall, and that firewall is sending the fabric a default route. That default route is being leaked into both of the tenant VRFs, and then we obviously want that route to be advertised further out into the fabric. That doesn't happen by default. There's certain commands that we need to use under the VRF, and I just want to show what those commands are, because there's two very important commands that differ slightly in what they do, and just show how they're used and the direct impact of those commands being entered under the VRF. So all this configuration is going to be done on our border leaves, which is leaf 3 and leaf 4. Because I'm in a VPC enabled environment, we elect two border leaves that are within the same VPC domain. So let's just have a look on leaf 3 and 4 just to verify what we've got. So we've got three main VRFs, so overlay tenant 1 and overlay tenant 2, and then this external VRF here. This is the exact same on leaf 4, as we can see there. So if we look at show BGP VRF external IPv4 unicast, let's just do summary on that. So we can see in here that we have got this peer here. This is the firewall. We will see on leaf 4 as well. Again, this is the firewall. We're receiving one route from the firewall. So if we get rid of that, we'll see that this is the one route here that we're receiving from the firewall. It's the default route, as I said. So that we're receiving on leaf 4. And then again on leaf 3 we are receiving the exact same route. If we look at the IP routing table for that route in VRF external, we can see that it's there. It's via BGP with an eBGP AD of 20, sorry, and we can see that it's come from that autonomous system there with the tag. Copied and pasted it with the tag that Nexus adds. So we can see that route there. If we do a show run section VRF, we can see, if I scroll up, this is our VRF context for the external VRF. We've got RD Auto on there, so the autonomous system we're using is 64500. The automatically generated route target for this VRF will be 64500:100,555. So as you can see, in these two tenant VRFs, we're importing that route target, which is what we'd expect. It's just standard route leaking between. And then in the external VRF, we're importing the routes from the two tenant VRFs. So we can see that we're importing 998 and 999, and we're also importing the EVPN routes. So if we look in the actual routing table for the full routing table for the external VRF, we'll see in there that we've got our default route as expected. We've got a summary route, which I'll show in a second, and then we've also got /32 routes in both 10.1 and 10.2, which are our two tenant VRFs. So 10.2 being overlay tenant 2 and 10.1 being overlay tenant 1. But the most important part of that is that we do see these EVPN routes in here. If we were to come into here and say VRF context external address family IPv4 unicast, and whereas in here we've got these EVPN ones, if we were to come into here and say no to those, and then come back out and look in our route table, we can see that we have considerably less routes because we lose the /32. So that EVPN parameter there is saying that we want to import EVPN routes that live in that target, route target essentially. So without that, we don't get the routes that we want, and essentially it won't work because we do need the /32 routes because they're the ones that are encapsulated in VXLAN. So we'll add those back in. Ooh. Like so, 998. And if we do that again, pretty much instantaneously, we should, get more routes, which is what we expect. So this default route then, this is at the minute in here, it's an IPv4 unicast route. This, as we said, was being leaked into the overlay VRF. So if we look at show IP route VRF overlay tenant 1, and let's just, there could be a lot of routes in here, so we'll just make that a bit more specific. We can see here that it has definitely come from the external VRF because we can see that it's via, and you can see here via the VRF, we can see it's via the external VRF, and we can see that it's still that route because it's got the eBGP AD of 20, and we can still see the tag of 64520, which is the autonomous system number of the firewall. If we were to do this exact same command on a non-border leaf, i.e. leaf 1, that command, or the command works, but the route doesn't exist. And there's a very specific reason for that, because by default, when you leak between two VRFs, it will not advertise, or won't by default allow you to advertise routes that have come from another VRF into a BGP VPN. That's the specific wording that Cisco use in a white paper that is available online, which I'll link down in the description. But essentially, by default, they do not export routes that have been imported from another VRF into EVPN. We have to specifically enable that feature. So what we'll do is we'll do it, well, I mean, we may as well do it on both leaf 3 and leaf 4. So this is a configuration under the VRF. So VRF context, and we'll just do it for the minute in overlay tenant 1. It's under the address family for IPv4 unicast, and we say import VRF advertise VPN. And if we use context sensitive help on that, we can see that advertise VPN allow leaked routes to be advertised to VPN. Essentially, this is a leaked route in the overlay tenant VRFs. So this is us saying we're allowing those leaked routes to be advertised into the VPN, which is eVPN. So we'll enable that there, and then on leaf 4 we'll do the same thing. Perfect. And then pretty much instantaneously on leaf 1 we should see that route, and we do, and we see it via both the border leaves. So that command has essentially allowed us for imported VRF routes to export them into the BGP VPN, which is eVPN. The other thing to note is in these VRFs, if we look at show IP route VRF overlay tenant 1, in here there's more than just the default route. There's also all these other /32s. So if we look down here, so for all intensive purposes, overlay tenant 1 is 10.1. We can see that we've got all these 10.2 routes in here, which have come through the route leaking. These, if we do the same command on, for example, leaf 1, we don't see those. We see our /32s for 10.1, which is the local VRF essentially, but all we see in here is a /16 summary and a /24 route that's been advertised, we don't see those /32s at all. And there's another specific reason for that, in that BGP doesn't allow those to be advertised by default. We have to explicitly allow it. And if we have a look on leaf 3 in show BGP VRF overlay tenant 1 IPv4 unicast, we do see those routes in here. So this is overlay tenant 1. We see 10.1/32, 10.1/32, and then 10.2/32, and 10.2/32. But these never actually make it to our other leaves because we don't allow that to be advertised. So there's another command which we have to use under the VRF, which is an export command, which essentially enables us to allow routes that are imported from a BGP VPN to be exported to a non-default VRF. So this is on the opposite side than you would think. So in order to have leaf 1 have routes for 10.2, we have to enable that on the overlay tenant 2 VRF, because that's the originating VRF that those routes come from. And we'll prove that now. So if I come onto leaf 3 and come into VRF context overlay tenant 2 address family IPv4 unicast, and if we say export VRF allow VPN, and if I context sensitive help that, we can see allow re-importation of VPN imported routes. So if we think about the way that the tenant VRF works, the tenant VRF is essentially importing its own VPN routes, and in doing this we're allowing the re-importation of those routes from the other VRF that we're advertising these to, which is overlay tenant 1. So if we configure that, it might take a second because this does rely on BGP to, in the background, generate all the BGP updates. So before, with this command, show IP route VRF overlay tenant 1, we've obviously now got the default route. We've got all of our 10.1/32s, but for 10.2 we only had a /16 and a /24. If we do this again now, we can see that now we've got these two routes that have appeared, which are essentially 10.2/32 routes, and that's enabled these routes to be advertised to not only this leaf. If we do this on leaf 2, we'll see a similar output where we've got those in there as well. So that command is a bit counterintuitive in that you need to enter it on the source VRF rather than the destination VRF. We had to use the import command on the destination VRF, but the export command is on the import VRF, and that's now enabled this route table to be populated with routes that have come from outside the fabric and routes that have been leaked within. There's not normally a reason that every single leaf would have to know about all of the /32s, because that's mainly what we use this summary address for here, to essentially attract that traffic to come over to the border leaf, and then the border leaf has got, beefier routing tables which will configure that leak in between. So hopefully that's been useful.